Yes, student, next one is ionization enthalpy. Student, ionization enthalpy is the amount of energy required to remove outermost shell electron which is most loosely bonded. This is the definition of ionization enthalpy. Student, you know that ionization enthalpy is inversely proportional to atomic size. Means what? As bigger the atomic size, lesser will be the ionization enthalpy. Why? It is because if the size is big, that means the proton and the electron are very far from each other, then what? Then the nuclear attraction force will be very low, and if the nuclear attraction force is low, then the removal of electron require lesser energy. Student, you know that in case of alkali metal, their size is biggest in their respective period. That means what? The ionization enthalpy will be lowest. So we can say here ionization enthalpy of first group elements are what? Least in their respective period. Okay, now why beta? It is because their atomic size is largest in their respective period. If we think about the ionization enthalpy like lithium, sodium, potassium, rubidium, cesium, and the francium is the last element. Okay, the ionization enthalpy of lithium is 580. This is what given in kilojoule per mole. Okay, 520. This is because the size of lithium is what? Smallest, and being its size is smallest, therefore its ionization enthalpy is largest. But as we move down the group, now the size of sodium become what? Higher. That means what? Its ionization enthalpy will become lesser as compared to what? Lithium. So what we can say? We can say ionization enthalpy down the group decreases gradually, and it depends on what? It depends on what? Atomic size. As the atomic size will increase, it will what? Decrease. Like it will become 413, it will become 403, and it will become approx 396, and so on. So this is about ionization enthalpy. So along the period, ionization enthalpy is least, and again down the group, the ionization enthalpy decreases. Next one is density. Okay, alkali metals are least dense. Okay, why? So we can write explanation. Why beta? Because their atomic volume is biggest. So you know that density is what? Mass upon volume. As the volume will increase, the density will decrease, because density is inversely proportional to volume. You can say here density is inversely proportional to volume. So if the volume will increase, the density will decrease. Student, sodium, potassium, lithium are even lesser dense as compared to water. That means if you drop a piece of lithium, sodium or potassium, you will find that they remains in upper surface of water. This is due to their low density. But as we move down the group, that is rubidium and cesium, now the density will increase. The increase in density is due to increase in molar mass, and you know that density is directly proportional to molar mass. Okay, like we can say density is directly proportional to mass. So if the mass will increase, the density will also increase. So down the group, density increases. Getting? Now, the next property is oxidation state. Oxidation state. Okay. All elements shows only one, okay, oxidation state, which is what? +1. That is, there is no any other oxidation state shown by alkali metal. Why? Because they have only one electron in what? Valence shell. So to get octet, they can lose only what? One electron. That is, you can say Na can lose only one electron and become Na plus an electron. Student, being their atomic size is largest, the facility to release electron becomes very easy. Okay, therefore they shows only one oxidation state, which is what? +1. Even exceptionally, they do not shows any other oxidation state. Okay, in redox reaction, I have already given it in notes. Okay, alkali metals are highest electropositive among all elements of periodic table. It is because they can lose electron very easily, because their ionization enthalpy is least and the atomic size is highest. So in this way, you can compare some properties of alkali metals.